So there are two ways you guys are going to solve equations with rational expressions in them. So the first way is going to be cross multiplication, and the second way is going to actually be eliminating the denominator. So the first method we are going to do is cross multiplication. So you can only do cross multiplication if you have one expression on each side of the equal sign. So if you have more than one thing on one side of the equation, you can't cross multiply. Cross multiply is only used when you have one term on one side and one term or one expression on the other side. So one expression on each side, one fraction essentially. So because that's like our example one, we can do that. So if we cross multiply here, this is where we said if you have an equal sign, that's when you cross multiply, not when you're just trying to multiply fractions. So we're going to multiply diagonally or across, and this is an equation, guys, so we still need to end up with something being equal. It still needs to be an equation even after we're done cross multiplying. So what happens is we take 3 times 4x plus 5, and that is one side of your equation. And then you take 9 times x plus 1, and that's the other side of your equation. And then you guys just go from there. So the left side will become, after you distribute that 3 in there, 12x plus 15. And the right side will become 9x plus 9. So again, it's not a quadratic, so it doesn't really matter what side you move things to, but you want your x's on one side and your constants on the other. So I'm going to move my 9x. So we get 3x plus 15 equals 9, and then we're going to subtract 15. And get 3x equals negative 6. So when we divide by 3, we get x equals to negative 2. And whenever you guys are just solving for an equation, remember you guys can always plug it back in to check that it makes your equation true. Now, a little further down here, we will check for those extraneous solutions to make sure that the solutions we have, whether it's one or two of them, all work. It usually is only a case that we have something that doesn't work if it is a quadratic, where we usually have two, but you always want to check. And I can tell you that negative 2 does work here. So the other way we have for solving quadratic or solving rational equations is by eliminating the denominator. So if we go over here and look at number 2, if we try to create a lowest common denominator out of all three denominators that we have here, what does the common denominator, or what would the common multiple of those three fractions be, is what we're looking at. So we can actually say lowest common multiple instead of denominator. So of x4 and x, we would only need a single x, no more than one, and a 4. So because this is an equation, we have to keep everything balanced. So as long as whatever we decide to do, we do it to the whole equation, it is fine. To multiply by. So what I'm going to do is multiply the whole equation by 4x over 1. We don't want to do it by 4x over 4x because then we're just going to multiply all of these together again and we're not going to eliminate anything. So we do it over 1 so that each fraction has something that's getting eliminated by this common multiple that we're using. So for 5 over x, the x is going to cancel with the x in the common multiple that we're multiplying by. So we have to multiply the 5 by 4. Or we could also look at it this way. You could distribute the 4x inside to everything. So this would become 5 times 4x over x plus 7 times 4x over 4 equals negative 9 times 4x over x. So if you distribute that 4x to all those numerators in there, then you guys can see maybe better what cancels out. So what happens, they will cancel out, the 4's will cancel out here, and your x's cancel out in the last one. So maybe that's a little easier way for you guys to see that. So then what happens is we're left with 5 times 4, which is 20, plus 7 times x, which is 7x, and negative 9 times 4, which is negative 36. And then you just have a normal equation to solve for. So I'm going to subtract 20 and get 7x equals negative 56. We would divide both sides by 7, and x would equal negative 8. So that is our second way, eliminating the denominators by multiplying by a common multiple of those denominators. So let's look at one more like that. So let's look at number 4. Just like when we add and subtract, if we need to factor the denominators, I would do that first. So x squared minus 9 can be x minus 3 and x plus 3. And I'm just going to sort of cancel that out because we've just sort of rewritten it now in a different form. So if we're trying to find a common multiple of all 3 of our denominators, it would need to include a single x minus 3 and a single x plus 3. None of our fractions has more than one of either of them. So we are going to multiply the entire equation to keep it equal and balanced by x plus 3 and x minus 3, but over 1. So if we distribute these two these two terms inside all 3 things, so we'll have 6 times x plus 3 and x minus 3 over that denominator still equals 8x squared times x plus 3 and x minus 3 over x minus 3 and x plus 3. Now, if you guys begin to see what happens, and you don't need to do this step, that is absolutely fine. I'm just doing it sort of as a visual. And then we'll have minus 4x times x plus 3 and x minus 3. So everything gets that x plus 3 and x minus 3, and we just keep it over the current denominators it has. Now, once we've done that, we'll go back through and see what cancels out. So for the first fraction, these would cancel. For the second one, they actually both would cancel. And then for 4x, for your last one, the x plus 3's cancel. So it's a lot of extra writing distributing it in there. So if you guys understand that this 6, the x minus 3 cancels, and it just needs that x plus 3, that is fine. But that's what we're doing there. So the 6 times x plus 3 becomes 6x plus 18. And then your 8x squared is just 8x squared because all of your other terms canceled. And then the 4x is getting multiplied by x minus 3 because this guy is gone. So minus 4x squared minus 12x. So we've got 6x plus 18 over here. 8x squared minus 4x squared gives us 4, and minus the negative 12 gives us plus 12x. So because it's a quadratic, this is an equation where we're going to have to move everything to the right side with the x squared. So I'm going to subtract this 6x and 18 over to the other side and get 0 equals 4x squared plus 6x minus 18. Now, you guys can go right from there to factor it, but if you want to make your lives a little easier, we could factor out a 2, and then your numbers get a little smaller because all of those values are divided by 2, and we'd be left with 2x squared plus 3x minus 9. So we would have to then factor, what we have left here. So that would mean, since the lead coefficient is not 1, you would have to use the box and the diamond here, but I'm just going to reverse pull and do it in my head. So the only thing that multiplies gets you 2, x squared is 2x and x. And the only things that multiply to get you 9 are either 3 and 3 or 9 and 1. So let's do 3 and 3. So that would be 3x, that would be 6x. That does get us to 3 if we do 6 minus 3. So what you guys would have to do then is set both of those factors, 2x minus 3 and x plus 3, equal to 0. So you end up with x equaling 3 halves and x equaling negative 3. So when we need to check for extraneous solutions, the reason I know that negative 3 isn't going to work is because negative 3 would be a domain problem. Negative 3 plus 3 makes your denominator 0. So that would be an extraneous solution that wouldn't work because you can't divide by 0. So in this case, your only answer would be x equals 3 halves. Negative 3 is not a solution. So if you guys want to try number 3, it might be helpful if you guys put the value of 1 over 1 and then figure out what you have to multiply all 3 of those expressions by in that fraction or in that equation. And then try number 5.